Hello, and welcome to our webinar with Romer Labs and BRCGS. We're so happy to have you here today, and we're going to go over some great content. But before we start, let's go through a few housekeeping items. First item on the docket, we will be doing introductions of our speakers. We're going to go through a presentation with Barry and then with Christy, and then we'll be available to answer some questions. If you have a question, please use the Q&A box that's available in your right-hand corner. And from there, you can type in your question and we will answer it to the best of our ability. If we don't get to your question today, don't worry. We will be sure to reach out to you at a later time. Barry Meikle had gained a BSc in Environmental Health from Cardiff Metropolitan University in 2015 and spent the next 2 years with the Food Standards Agency in Wales. He immigrated to Canada with his wife and son in November of 2017 and found employment with the Allergen Control Group. With ACG, he was responsible for providing technical support and guidance in relation to the gluten-free certification program to customers, auditors, and certification bodies. ACG were acquired by BRCGS in mid-2018, and since then, he has continued in this role, but has expanded his knowledge to be able to provide support for Food Safety Issue 8, agents and brokers, and the plant-based standard. Christy has over 18 years of experience in the field of food allergens. Christy currently holds the role as Technical Services Director at Romer Labs. Driven by her passion for food safety, Christy participates in various industry organizations, such as AOAC, including various working groups, cereals and grains associations, and AAFCO, providing valuable market insight and continuing to expand her knowledge and expertise. As Technical Services Director, Christy is responsible for managing Romer's ISO 17025 accredited analytical services lab offerings analysis in both food allergens and mycotoxins. Additionally, Christy manages the Romer Labs North American technical support team, providing technical and customer support for all Romer Labs products, including our line of food allergen detection methods. Christy received her Bachelor of Arts in Biology and Chemistry from Drury University, Graduate Certificate in Food Safety and Defense from the University of Missouri, Columbia, and a Master's of Science in Food Science from Kansas State University. Without further ado, Barry, take it away.
Good morning, good afternoon, or good evening. My name is Barry Meikle, and I'm the Technical Manager of the Free-From Standards at BRCGS. So, before we talk about managing allergens, let's just have a quick overview of what an allergen is. An allergic reaction occurs when the immune system overreacts to a normally harmless protein substance known as an allergen. The first time a person with an allergy is exposed to the allergen, it may not cause a reaction. However, the person is insensitized, and even minor future exposures can produce an allergic reaction. Unfortunately, food processing induces several physical, chemical, and biochemical changes that are known to potentially impact the allergenic potential of proteins. Certain methods of food processing may enhance, reduce, or eliminate the allergenic potential of a food, making the allergic consumer react in different ways to the same allergen in two different foods. For many years now, undeclared allergens have been the leading cause of food recalls. 50% of USDA food recalls are caused by undeclared or misbranded allergens. Meanwhile, 45% of the FDA's recall press releases in 2020 were caused by a variety of errors associated with allergens. Many of these recalls are due to labeling errors, such as the omission of allergens on product packages and using incorrect labels on products. Scientific research and legislation have helped us understand a great deal about managing food allergens in manufacturing, yet so much more needs to be done in making these risks safer for the growing allergic population. So what can a food manufacturer do to mitigate this problem? Well, the first step is to introduce an allergen management program. So these are the key areas of what constitutes an effective allergen management program: risk assessment, raw materials, cross-contamination, control of rework, cleaning, allergen claims, packaging and labeling, and finally, training. So let's start with risk assessment. Risk management starts with risk assessment, which for allergens requires consideration of, at a minimum, the likelihood that they are present, their physical form, powder, liquid, pieces, etc., as well as the amount of any allergen present. Risk assessment must encompass every component of the supply chain, from raw materials, supply specifications, to the sale of the finished product, and including product design and development. This evaluation should be carried out by personnel appropriately trained in allergen management. You will need to understand and identify the allergens on site. Raw material assessment and specifications can be used to assess the risk. Next, you will need to understand the hazard, which in this case is inadvertent consumption of an allergen. Identify the products which do not contain the allergen and implement controls to reduce or eliminate the risk of cross-contamination. Next, you need to understand the likelihood of contamination. Consider the location and all process steps. Use the site plan and the site's process flow diagram to identify potential sources of contamination. The next step is to identify controls. Where a risk has been identified, can the risk be removed or reduced to an acceptable level, such as with gluten? Consider existing controls you have on site. Are additional controls needed? Finally, you need to review the risk assessment. Do the new controls reduce or eliminate the risk appropriately? So next, let's move on to raw materials. A manufacturer can only perform their own risk assessment effectively if they are in possession of correct information about the complete allergen status of the raw materials and ingredients used. This requires knowledge of each supplier's understanding and application of allergen management. Manufacturers should have programs in place to assess the allergen control programs of suppliers when necessary. For example, a supplier questionnaire, survey, or an audit to assess the allergen profile of foods produced at the supplier's site and the supplier's allergen management plan, including allergen cross-contact controls and cleaning programs. A specification sheet, certificate of analysis, or vendor guarantee periodically or with each lot can be useful in addressing a supplier's control of food allergens, as well as occasional testing for undeclared allergens when necessary for verification. You will need to understand the allergen risk analysis from each supplier in order to apply the analysis appropriately and consistently to their products. Ensure that information from suppliers is correctly recorded, including complete allergen status. Lay down procedures on how information received from the supplier is handled, processed, and acted upon. Make sure a change notification process is in place with the supplier so that newly identified allergen risks for ingredients that are already being supplied are properly notified and can be acted upon. When developing new products or changing formulations or ingredient suppliers, manufacturers should consider whether it's feasible to use a non-allergenic ingredient to provide the same functionality as an allergenic ingredient to avoid introducing a new allergen into the establishment or processing line. So next we move on to cross-contamination. Documented procedures for the control and prevention of contamination must be in place and visible or readily available to all employees in the work area. The procedure should contain information about product development guidelines in terms of allergens, good hygiene, for example, rules regarding clothing, hand washing and hand contact with foods, cleaning of premises, equipment and tools, handling of rework materials, for example, the conditions under which such product may be used, waste management, for example, how waste should be labeled and kept separate from rework, situations where potential cross-contamination can occur between raw materials, products, production lines, or equipment, and each employee's responsibility for preventing this, production scheduling, and labeling of raw materials, semi-finished goods, and finished products. Changes to any process within a food production facility or introduction of a new raw material or product can affect allergen cross-contact risks for other products manufactured at the same site. Changes to any process within a food production facility or introduction of a new raw material or product can affect allergen cross-contact risks for other products manufactured at the same site. Any changes will therefore require a reassessment of the original risk for all potentially affected products and, if required, application of new risk management measures. Any new relevant risk identified which cannot be reduced further will need to be communicated to customers, for instance through advisory labeling. So next, let's move on to control of rework. Defined procedures for the handling of rework in production must be in place. Ideally, the principle should be identical into identical, i.e. rework should go into another batch or run of the same product. Where this is not practical, allergen-containing rework should only be used in products where that specific allergen is already present. Oils used for cooking allergenic foods, for example, shellfish, fish, and breaded or battered products, should not be used subsequently for cooking products not containing that allergen without undergoing a validated filtration step. Alternatively, the site can schedule production so that, for example, products containing gluten are produced after gluten-free products. The use of rework material containing allergens must be properly managed and documented. Storage, processing, identification, and labeling procedures must all be the same as those for the original allergens. Responsibility for the management of rework must be clearly defined. So let's now move on to cleaning. Effective cleaning is one of the most important aspects of allergen management. Line cleaning must be evaluated for its ability to control the hazard. Documented and validated cleaning procedures using proper cleaning equipment are essential to ensure that effective cleaning is performed and adequate time must be allocated for cleaning. Cleaning practices that are satisfactory for microbiological safety may not be adequate for removing some allergens. Equipment may need to be dismantled and manually cleaned to ensure hard to clean areas are free from allergen residues. Particular food materials, for example, powders, seeds, pastes, and particulates, may present significant cleaning problems, and any relevant industry guidance should be followed. Procedures should be in place for cleaning both production and packaging machinery. The actual cleaning process must not contaminate the other areas, for example, by use of compressed air, or an area which has already been cleaned, for example, clean dry mix areas from the top down. Any spillage that occurs during production, storage, and transportation should be cleaned up immediately to ensure there's no subsequent allergen cross-contact. Allergen claims. Any claims regarding allergens that are made must be truthful and not misleading to the consumer. Consider the claims which may be allowed or not allowed by any third-party allergen certifications you may hold. For example, some gluten-free certification programs allow the intentional addition of gluten, provided the finished product meets the requirements for gluten-free in the country of sale, while others, such as BRCGS's gluten-free program, do not. You should also consider whether the certifications allow you to make claims on the certification status of the product itself or not. You should not restrict the accuracy of claims solely to the labeling of foods. They should also be applied to any form of advertising and presentation, which includes, for example, off-pack labeling, such as websites, leaflets, product lists, consumer care lines, and shelf labels. When making claims, manufacturers must be careful not to fall foul of regulations which govern nutrition and health claims. You must not advertise your product in such a way as to suggest it has any nutritional benefit or benefit to health unless those claims are substantiated. So let's move on now to packaging and labeling. As I mentioned earlier, incorrect packaging and labeling is a major cause of allergen-related product recalls. Procedures for checking that the correct labels are applied to products should be implemented so that accurate information is provided to allergic consumers. Checks should be in place between processing and packing to ensure the correct packaging is used. If packaging is stored, even for short periods, in processing areas, there is the potential for cross-contact with allergens. Production planning should include the order in which different products are manufactured and packaged. Special attention must be paid when production takes place at one location and the packaging of the finished product is done elsewhere. Product labels should be designed and verified to match the formulation, before the new product or changed formulation is produced, and product and label specifications that are no longer used should be destroyed to prevent accidental use. Where there's a change in the formulation which results in a change of allergen profile, manufacturers should consider indicating this on the packaging and on their websites. It's important that following recipe changes or the introduction of a new allergen cross-contact risk, etc., the old packaging is not only withdrawn from use, but is physically destroyed so that it cannot be used in error. It's also essential to ensure that the product is packed in the correct packaging. If packaging variants are of similar appearance, such as for different flavors, additional controls are recommended. There should be systems to ensure packaging is removed at the end of a run, including any packaging that may be within the wrapping machine. This will help to avoid packaging mix-ups when the product to be packed is changed. Finished products containing allergens should be securely packaged so that they cannot contaminate other products. So now finally, let's move on to training. In order for any allergen program to be effective, everyone involved in the commercialization, production, and distribution of foods should understand the implications of the presence of food allergens and the need to manage the ensuing risk. Therefore, individuals, whether it be top management, marketing, internal auditors, product developers, design engineers, plant personnel, and contractors or employees handling consumer complaints, should receive specific training to their job responsibilities in this area. They should become aware of measures needed to minimize the risk of allergen cross-contact. All appropriate personnel should be encouraged to take immediate action if any risk of contamination is suspected. Allergen training should be provided to all new employees during orientation and should be repeated on a regular basis. Any visitors to the site should receive appropriate induction according to site GMP rules. Incorporating different learning methods will help get the message across. Training can include general allergen awareness, including the serious nature and possible health consequences of the unintended or undeclared presence of allergen in products, awareness of the likelihood of allergen cross-contact identified at each stage of production, good hygiene practices, for example, appropriate clothing, hand washing, and minimizing hand contact with foods to prevent or minimize allergen cross-contact, and cleaning of premises, equipment, and tools, including clear between product cleaning instructions. Occasional testing and validation of applying this knowledge ensures the integrity of your allergy-free claims and establishes trust. Passion and commitment also play a vital role in achieving success in your program as a whole. So that's the end of my presentation. Thank you very much. I will now hand over to Christy from Romer Labs, who will discuss appropriate test methods and the various test kits which are available. Christy?
Hello, everyone. As Barry has already focused on the gluten-free standard and items necessary for compliance, I'll now transition to discussions on one piece of that compliance, but a large piece, which is how to select the most applicable gluten detection method for your facility, your products, and your processes. We'll talk about various different gluten detection methods available, how to select the correct one for your specific need, limitations to test kits available on the marketplace, and some suggestions for how to overcome those limitations. Just to recap, why test for allergens, and more specifically gluten, especially if we have done our due diligence and performed our risk assessments to ensure we have gluten-free ingredients coming into our facility for production. Vendor verifications are not enough. Testing finished product only is not enough. We need to ensure that the production environment and the production equipment is controlled continuously to avoid unpredicted contamination. And to do this, we need to effectively utilize those vendor verifications, ingredient verifications, environmental sampling and testing protocols, and also finished product testing. Every step of the process needs to be continuously monitored from receiving incoming ingredients to shipment of the finished product for retail. A few of the dominating reasons that drive us all to strive for the gluten-free production environment are to ensure the public health while ensuring our food is safe for susceptible individuals to consume. Some of the other reasons for ensuring continued compliance relate to our brand protection, selling products within the allergen-free market, avoidance of product recalls, and to meet legislative guidelines. With testing, however, comes some analytical challenges. We'll spend some time over the next several slides talking in more detail regarding these challenges and how you can overcome them. The challenges can include effective sampling protocols and techniques for a realistic analysis of potential gluten contamination. We'll talk about matrix effects. Matrix effects are food ingredients or food samples that have an adverse impact on a test kit's ability to accurately detect gluten within that sample. We'll discuss effects that various forms of food processing can have on gluten detection methods. We'll touch on how to compare test kit results from different manufacturers or different platforms, such as a lateral flow device result with an ELISA test kit result, especially when those results are not aligned. And how should these results be evaluated in lieu of reference materials or gold standard methods in the industry? And lastly, we'll provide a few comments of ours about selection of a third-party testing laboratory for your gluten analytical needs. Appendix 5 of the BRCGS standard provides framework guidance on best practices for sampling and testing for gluten as part of your risk management assessment. Their approach is a 5-step approach. Step 1 is to evaluate the risk of contamination. Perform your supplier qualifications, ensure identification of cross-contamination sources, and assess risk for incoming materials and processing steps. Step 2 is to define your sampling parameters. You'll need to define the frequency of sampling, the amount of ingredient or surface or product to sample, the sampling method you'll use, what type of sampling tools you have available, the preparation method you'll use to collect your samples, and the number of tests that will be performed as part of the sampling evaluation. Step 3 is to determine the testing methodology. You'll assess various testing methodologies available on the market to confirm those that are appropriate for testing each of your matrices. Will you be implementing on-site lateral flow device test kits, implementing analysis using an ELISA test kit, sending out to a third-party lab, or seeking reference test methods such as LC-MS? Step 4 is to interpret those test results. Identify your acceptable criteria. Is it less than 20 ppm gluten? Or are you looking for less than 10 or even less than 5 or some other internally developed threshold? You'll need to establish your risk assessment for how you will proceed in case positive results are obtained. What type of investigation will you conduct as a result of those positive results? And how will you take action as necessary based upon them? Step 5 is to validate this entire sampling program. So it's validating of steps 1 through 4. This includes validation of your cleaning and sanitation programs as well, validation of your sampling program in total, and validation of your test kit methodology, possibly including matrix-specific validations by the kit vendor and validations of your product specific for gluten analysis. We'll start with sampling. This is critical and there are many questions surrounding sampling. A thorough sampling plan will be the result of risk analysis for each facility and the product being produced. Items to be considered during the risk analysis include the recipe used, where your raw materials are sourced from, the storage areas of both the raw materials and the finished products in your facility, the production process employed, focusing on weighing, mixing, and individual production lines, the carryover potential for allergens due to your cleaning processes, and even your staff. Based upon your risk analysis, you can determine where you should be testing. Is it in raw materials, or the finished products, or a combination of both? How often should samples be pulled for testing? Based upon what are your production cycles? Are you in an allergen-free facility, or do you have dedicated allergen-free production lines, or are you operating on shared production lines? And lastly, what are you most interested in monitoring through your testing protocols based upon your perceived risk? Those raw ingredients again, finished products, rinse waters, critical control points, or surfaces via swabs. We'll next move into matrix effects and how vastly significant understanding a potential matrix effect on a test kit result can be. The matrix effects or potential matrix effects that a food ingredient or finished food product can have on a test kit method are numerous. No two food products, especially finished food products, can be viewed as equal. The uniqueness of the ingredients, the finished product, the factory, and the production processes, and even your cleaning procedures should be considered when discussing possible matrix effects. The ease of gluten detection considers the testing methodology's ability to accurately detect gluten in food samples, both in raw ingredients and finished products. This measure can be influenced by some interfering food components, as some products are more difficult to analyze than others. Those foods that are more difficult to analyze for include those that contain high amounts of polyphenols, like clove spices, cocoa powder, vegetables such as spinach, onions, or potatoes, millet, buckwheat, chestnut flour, or various other nut flours. High tannin levels such as dark chocolate, tea, coffee, wine, hops, and berry fruits. What is the pH level of the product? Specifically, if the matrix is too acidic and the pH range is below 6. Is the product high salt? Does it have a high fat content? What is the inclusion rate of food gums? What types of food additives were included? These are all components of a food product that can affect the analytical detection of gluten, and therefore could ultimately reduce the test kit accuracy. There are a few things we can do to help offset some of the matrix effects on a test kit as just described. The addition of additives such as fish gelatin or skim milk powder can be beneficial. These items aid in extraction of gluten for the detection, and they can also aid in reduction of nonspecific binding, which could lead to a false positive from the matrix effect. Other options are to further dilute a sample for the analysis. In essence, dilute out the matrix effect. An adverse consequence of this, though, is that higher LODs and LOQs can be obtained, so it isn't always a viable option for some producers. We can add in a centrifugation step to the lateral flow method, and this helps to purify the sample extract, which sometimes aids in flow of liquid up the strip, which will offset the matrix effect impact. And lastly, we can add additional washing steps to an ELISA method. A typical ELISA method uses 4 to 5 washes per incubation. We can increase that to 5 or 6 washes, for example, to help pull more compounds from the plastic ELISA wells, which can reduce the impact of matrix effects as well. The majority of food products consumed today are considered processed. Processing can include everything from mechanical or chemical manipulations to heating and extruding of products, to hydrolysis or fermentation, and distillation of products, to name a few. As a simplistic rule of thumb, processed foods are those that come in any type of container that require an ingredient list. Some types of processing, such as pasteurization, canning, irradiation, and dehydration, to list a few examples, do not pose significant challenges in food allergen detection. However, various forms of processing do result in protein conformation changes, as often the gluten proteins aggregate under these conditions, making extraction of the gluten for analytical purposes more difficult. The most commonly discussed adverse type of food processing are hydrolysis, fermentation, and then distillation. Through either of these types of processing, the protein is altered and the allergen cannot be detected in its natural state. Hydrolysis is a salt, acid, or base reaction that occurs with water and results in peptides being formed within the food product. These peptides are a result of breaking down the gluten protein into smaller fragments. Fermentation is a breakdown of substances by bacteria, yeast, or other microorganisms. The process of fermentation is also often involved in the making of beer, wine, and other liquors, in which the sugars are converted to ethyl alcohol. Sandwich-based ELISA test kits are not appropriate for these types of food samples, as the gluten peptides present are too small or have been altered in form to an extent that the 2 antibodies present in a sandwich ELISA cannot be attached to effectively. If analysis of food products following hydrolysis or fermentation is necessary, then a competitive ELISA test kit is your best option. Food products such as beer, sourdough breads, vinegars, soy sauces, xanthan gum, yeast extracts have all gone through hydrolysis or fermentation and should be tested analytically with care. The FDA final rule on labeling foods containing hydrolyzed and fermented foods was implemented effective August of 2020. It states manufacturers that desire to label these types of food as gluten-free must provide analytical assurance that their product is indeed gluten-free. This can be accomplished not only by testing, but by certifying ingredients are gluten-free before processing, performing the risk assessments on the ingredients in the production process, and analysis of the product for potential cross-contamination during or after processing. And they also must ensure that measures are in place to prevent introduction of gluten into the product during the production process. These requirements were put into place as the FDA also recognized that the test kits available on the market today are not fit for purpose in their ability to accurately detect gluten from a hydrolyzed or fermented product. Worthy of notation as well is that there is an exemption with the FDA regulatory framework. This exemption applies to raw agricultural commodities such as fresh fruits and vegetables. It also applies to highly refined oils that were derived from one of the 8 major food items and any ingredient that is derived from that highly refined oil. The distillation process is where a liquid food ingredient is heated to produce a volatile component where the desired alcohol and the flavors are separated from the proteins and sugars of that food ingredient. Vinegars of all types and alcohol spirits such as rum, gin, and vodka all go through a distillation process. Analysis of gluten should still occur following distillation for 2 reasons. The first being how effective is your distillation process in separating out the proteins and the sugars that are not desired in your finished product. If distillation is only partially effective, then gluten proteins can remain intact within your product. The second reason being cross-contamination of your distilled product with gluten in the further production of that product. If the production environment where the vinegar or alcohol is distilled is a gluten-rich environment, then the potential for cross-contamination does exist. It is important to note that vinegars can be additionally tricky for gluten analysis, as the grain or fruit that was brought into the vinegar process often started with fermentation first. For both the vinegars that undergo both fermentation and distillation, a competitive ELISA test kit will be your best option for gluten analysis. For the numerous reasons listed on the previous slides, including matrix effects, degrees of food processing that can occur, it's our recommendation that your test kit should be validated specifically for your food ingredient, your finished product, and your cleaning protocols prior to implementation to confirm it is fit for purpose. Test kit manufacturers conduct extensive validation studies on their products prior to test kit launch. The matrices included in these validations, however, are commonly available and tested matrices such as cookies, ice cream, chocolates, and so on. Validations by test kit manufacturers also include surface swab validations for your cleaning procedures. These include applying allergen directly to stainless steel, food-grade plastics, and Teflon for analysis. Validations are also conducted in rinse waters at various pHs and possibly include sanitizer interference studies. The manufacturer's validation will include gluten spiking of matrices in order to show acceptable recovery of that gluten in their test kit product. For ELISA food allergen kits, recovery of 60% to 140% is deemed acceptable. Based upon the vast assay of foods within the world, a general validation by a test kit manufacturer is not inclusive of all products. We know which types of products should work, which types of products won't work, and which types of products should be further evaluated through a specific matrix validation. It's highly recommended that you perform a matrix-specific validation prior to implementation of a test kit into your process. This is especially the case with implementation of lateral flow device test kits that you're using on a presence-absence basis at your facility. Not all matrices are suitable for detection of gluten on all test kits available on the market. A matrix-specific validation will demonstrate the compatibility of your matrix with the desired test kit. If validation of every food matrix is not possible for you or feasible, through your risk assessments, you should identify the more complex food matrices or those that are deemed higher risk and proceed with matrix validation specifically on those. Validation helps to confirm accuracy of results obtained on a lateral flow device. A proper validation should include both the analysis of gluten-free samples to confirm a negative result can be obtained at that desired LOD, as well as employing a gluten spike to test for recovery. For the spike, you should use a spike material to add gluten to your gluten-free material at a level greater than 20 ppm. This is then analyzed on the kit as well to confirm recovery of gluten and a positive result. It is very common to use something such as Vital Wheat gluten for a gluten spike for validation. Some test kit manufacturers offer matrix spike validations for customers as they will analyze your sample in their lab for conformance with the lateral flow test kit. If validation by the test kit manufacturer is not offered or not preferred, guidance of how to conduct your own internal validation is listed in the gluten-free standard in Appendix 5. Speaking of validations, we should also discuss the need to do a validation on your cleaning procedures prior to implementing them. This validation, unlike the previous two that have been discussed, should focus on the effectiveness of your cleaning SSOPs and not focus on validation of the test kit that you're utilizing. Most lateral flow and ELISA-based test kits have been validated by the manufacturer for their ability to detect gluten residues from swab surfaces and rinse waters. Test kit manufacturers have also performed validation studies on lateral flow devices, specifically to ensure that the sanitizer utilized does not adversely impact the test kit's ability to detect gluten. Validation of your cleaning procedures should be carried out on 3 subsequent production runs of the product and be reviewed at a minimum of annually or whenever a change to the cleaning procedure occurs. Currently, the analysis of food allergens is heavily dependent upon immunochemical methods that are antibody-based, including ELISA and LFDs. These are utilized today in food manufacturing and in analytical services labs. As the necessity for allergen detection continues to increase into more complex food matrices, the need for reference testing methods, including LC-MS and PCR, are expanding. All types of currently available methods come with a list of pros and cons for their application and determination for when they are fit for use and for your purposes. For today's landscape, we see manufacturers use lateral flow devices and ELISA test kits on site in their own labs. We see third-party labs using ELISA test kits in their 17025 accredited labs. LC-MS and PCR reference methods are not widely used within the industry today for regulatory compliance. We see these platforms utilized more for R&D or for confirmatory purposes. There is a huge effort globally for development and subsequent validation for LC-MS methods. A quick search online, and you will find methods available from manufacturers and researchers alike. As previously stated, there are pros and cons to implementation of any method, even an LC-MS detection method, which has led to a slow transition for third-party accredited labs. For analysis by LC-MS, samples must be digested to extract the glutens for analysis. This includes an overnight extraction step, which leads to longer analytical turnaround times. The benefit is that LC-MS methods are established on multiple peptide markers, so accuracy of detection is extremely high. LC-MS methods also allow for identification of wheat, rye, barley, or oats specifically based upon the peptide markers that are detected. The decision of which type of analytical method to use is a parameter that should be discussed and determined through a proper risk assessment. When choosing which method is right for you, things to consider include: what is the matrix being tested? So looking back at the impact of those matrix effects, those effects of food processing, or the formulation of your food product. Am I looking for detection of gluten in environmental samples? Secondly, are we implementing testing on site, or are we going to outsource to a third-party lab? What is the expertise needed if we decide to implement the different test kit methods on our site? What type of results are we interested in? Do we need a qualitative yes, no? Do we need a quantitative number? If so, we have to select an ELISA. Do we have a regulatory or a compliance issue where identifying the specific source of gluten is of interest to us? How quickly are we needing analytical results? Most lateral flow device methods can have results in around 10 minutes. A gluten ELISA method will take around 4 hours, and an LCMS method could take around 24 hours for those results. How does this time to result impact your production cycle? Are you seeking external verification of your results for some purpose? Do you need a third-party lab to certify that your product is gluten-free, or to do your cleaning procedure validation? Do we need to outsource testing to meet the requirements, or for an ease of application instead of implementing the testing protocols on site? And lastly, to close out, what about cost? What is the cost of implementing these methods or our testing plan to our company? When you're sending your samples, either ingredients, finished products, or environmental samples to an outside lab, there are a few topics to consider and confirm with your selected laboratory. Your first question to any third-party lab should include: are you ISO 17025 2017 accredited for the detection of gluten? If so, what methods are included in your scope of accreditation? What types of samples have been validated and have been shown to be fit for purpose using your defined test method? If all of those questions are answered and meet your requirements, then that lab is suitable for providing analytical test kit results to you for gluten analysis. Additionally, you could also ask your lab if they adhere to the AOAC guidelines for laboratories performing microbiological and chemical analysis of food, dietary supplements, and pharmaceuticals. It is not a requirement to adhere to these standards when holding ISO 17025 accreditation, but it does provide the end customer with additional confidence in the lab's ability to report consistently high-level analytical results to you. Based upon the gluten-free standard from BRCGS, it is stated that an accredited laboratory must be used at a minimum of annually to validate the production site's internal and contracted testing practices. This laboratory must have the ISO 17025 accreditation, with gluten methods included in their scope of accreditation, and with applicable matrix validations in place for your products. Romer Labs specifically offers many solutions for your analytical gluten testing and compliance needs. We are a company with a strong portfolio of antibody-based analytical tools, including lateral flow device test kits and ELISA-based test kits in 2 distinct platforms for use on site. Variations within these analytical tools allow us to customize a testing solution that meets your individual needs. Those variations can be the speed of use, the detection of raw products versus detection of allergen from roasted products, very high sensitivity of test kit methods, and also an ISO 17025 accredited lab with gluten analysis in their scope of accreditation to meet your analysis from a third-party lab requirement. And with that, I will close and turn things back over to Paula for any questions.